Okay, buddy, you're good.
Tiffany says hello, everybody. All right, can everybody hear me okay?
Yes.
Yes,
Can
sir.
everybody see my screen right now and my cursor moving back and forth?
Yes.
It's a little jumpy, but I got you.
Yeah. Okay. When you open Fusion 360, you're going to be presented with a big empty plane. Does everybody's screen look similar to mine right now?
Yes.
I have a grid.
Okay. Well, whenever you start a sketch, it'll end up on the grid. But we're going to go over some basics first. So in Fusion, we have our toolbar set up. My toolbar may look a little different than yours because you can customize this to things that you use frequently. I'm going to go through some things that you should pin to the toolbar and things that you should arrange in a way that makes your life significantly better in your Fusion 360 design process. This design tab, there's design, which we're going to be doing right now. There is generative design, which is a newer function that you can set parameters. You can say, I want to connect, like the case of this caster, the post to the wheel. What is the most AI advantageous way to do so? And it will connect those things. And you can say, I want to use additive manufacturing or subtractive manufacturing, and it will design the most optimal load-bearing element for you and then give you a way to actually either CNC it or have it 3D printed or have it milled. That is the one element that you have to pay for. I think there's like a free trial period, but I've never actually used it. I've just seen it being used in a group setting, but it's pretty cool. Render, if you want to make your element, once you're finished with it, look super pretty with dynamic lighting and different angles, and you want to actually make it look the way that you want a client to approve something, that arcade cabinet that I did right here, we sent this off to WB, to Warner Brothers, and had them approve the design based on a render of this cabinet. And I'll do a real quick one just so you can kind of see. We changed the background color because it looked like garbage. But anyway, rendering makes your element look really, really pretty, and you can change the lighting. Animation, the animation cell is not great. Just like in After Effects, you can create keyframes. You can take different elements and move them around, have them spin, have them like break apart into an exploded view. You can stack the animation elements on top of each other and make a little thing, but it's pretty glitchy. We tried to use it for a couple project videos, but I was pretty disappointed with how it all worked out. It's not bad, but it's not great. Simulation, if you want to do stress testing, you can assign different materials to your different parts. You can place a load. So if you're going to be doing like brackets for shelves or like a desktop, I don't know how true to life these things are because a lot of things that we're working with that I like to make stuff have been plywoods and thin plastics and things, and then we usually use furniture design books compared to like the engineering testing. It's just kind of nice to know. The manufacturer tab is something that is pretty awesome. You can take the 3D model that you are going to make. You can run CAD simulation, or CAM simulation, sorry. And CNC, you can run it to an X-Carve, to a Shapeoko. We run ours to a giant Avid CNC. You can do 3D relief carving, you can do 2D contours, all from the same model. I used VCarve and Aspire and Easel, which are great, but if I designed in Fusion, I would have to pretty much recreate what I was going to do in those other software packages, use that software, and then run it to the CNC. And so it was adding in like another unnecessary step. And so by learning and going through the CAM process here in Fusion, by loading your library of your own tools, it is so much faster. And lastly, the drawing, I've never used this. So we're working in the design. So up here at the top in the toolbar, we are working in the solid environment. You can also work in the surface environment, which allows you to structurally draw with a single plane. The Sheetmetal environment is pretty awesome. I've used it very, very little, but it's exactly what it sounds like. You can unfold things and you can give it dimensions, you can give it radius. People do like repeated pattern rolling pins. You can create something on a flat sheet, give it thickness, and then it will wrap itself around like it's a piece of sheet metal. You can unfold things, it's pretty great. And then lastly, tools are things that will help you along kind of in your post-processing. You can send something to a 3D printer. You can assign it a slicing software, Prusa Slicer, Cura, whatever, and it'll send your model as an STL to your 3D printer. This is the Shaper Origin plugin. There is a whole host of plugins on the Fusion 360's app page that you can get to make your whole workflow a lot better. This will take a face of a model that we're going to be making, and you can export it out as an SVG. If you just want to do like a 2D cut, or if you want to do laser engraving. This is a nesting app that I got. It's kind of garbage. I really don't like it. Make or Break Shop used it, but there's a better one. And lastly, these inspect tools I haven't really ever used. So we're working in the solid environment, which means we're going to be going from a 2-dimensional object to a solid 3-dimensional object. So up here in the Create toolbar, I have New Component, which is right there. To pin something up to the toolbar, you hover over these 3 little dots, or I'm sorry, you right-click on these 3 little dots. You can pin it to the toolbar. You can pin it to a separate shortcuts menu, which you can tap S and a little shortcuts menu will pop up, or you can assign a hotkey. Certain things I have hotkeys, certain things I have shortcuts, and certain things I have toolbars. I kind of have a stacked like order of priority in my head of things that I use frequently, but we'll get to these. So not that you have to make your desktop look like mine, but there is a method to this. So I always create new component and I bring that all the way over to the left because in Fusion, create a new component. Next to that, there's a sketch, create a sketch, then extrude, and then the forms. I mean, this is if you're going to be working in a mesh environment where you can push, pull a lot of organic shapes. And this is Mapboard. This is a separate app that we use to create cut lists for our woodworking projects. So those are the create toolbars that I have up here at the top. There's a lot of handy tools. A lot of them we're going to go over. Some of them we're not going to go over. In the modify section, there's press pull, which is very similar to extrude, but works a little bit differently. There's fillets, making a shell. The most important one that I did pin to this menu is the change parameters function. It is all the way down here at the bottom for some silly reason, buried in the menu. Right click on this, pin it to the toolbar. This is extremely important. Somebody mentioned SketchUp earlier. The parameters menu is what sets Fusion apart from SketchUp. It is parametric modeling. Parametric modeling simply means if you update a parameter, just like an Excel spreadsheet, it will update everything for you. In SketchUp, if you change one dimension, it is its own isolated little buddy and none of its friends will move with it. You got to move all the rest of it. Really frustrating. Parameters and parametric modeling is where Fusion 360 shines. Assemble. This is where you can make joints. You can make things move in relationship to each other. You can make drawers slide out, doors open. Construction planes. You're probably going to be making a new sketch. If you need to make one that is not actually touching the face of another thing you've already made, we'll make construction planes. And inspect tools is where you can measure the length of something. It already has a hotkey if you hit I. Some of these already have hotkeys assigned to them. I will measure stuff. One thing we're going to be doing is section analysis, which is pretty cool. You can kind of split it right down the middle and see if something is touching something else, if there's any kind of interference. So those are some of the toolbars at the top. Does anybody have any questions about these right now?
No.
Bueno. One other thing before we start doing any drawings or sketches is you follow my cursor down here to the bottom right, there's a little gear. The bottom bar all down here is where your timeline is going to sit. Your timeline is a sequential record of all of the different moves and processes that you have done in Fusion all along the way. Now, as we're working in this one project that we haven't saved yet, we're going to be creating components, and those components have bodies, and those bodies have sketches. Every time you add something or do something, it's going to appear down here on the timeline, which allows you to kind of go back in time if you mess up. But if you don't do the next thing that we're going to do with this gear, it's all just one big jumbled mess. So down in this gear, click this, you're going to click Component Color Swatch. Does everybody see that?
Yep.
Click that and trust me. Okay. So now you see up here at your unsaved project, it has a little color beside it, right?
Mm-hmm.
Sweet. So we're going to save this. I'm going to save this as Fusion Test. I spell it right. There we go. So once we save that, it should change this name. So the top level, wrap it all up, this is our project name. So your project name is really dependent on what you're going to be making. It's levels of priority. So if we're going to be making a drawer by itself is kind of useless. So if we're going to be making a bookcase, then maybe the entire project is named bookcase, and then the components of that bookcase are labeled underneath it. So it's really up to you how you want to organize yourself. But this entire tree over here is all for organization. I highly recommend labeling things as you go, because the deeper you get, and I'll show you an example, into some of these models, it becomes very difficult to know what you connected to other things. Just like the Excel spreadsheet analogy that I gave earlier, it'd be really nice if you could leave yourself little notes as to like how you came across a certain function. Because if you get many, many pages deep into an Excel spreadsheet and you don't remember how that thing was linked or what your intentions were a long time ago, if you want to change something, it becomes kind of difficult. So I'll give you an example. This is the secret office that we made on the Alex Make Stuff channel and where I am currently sitting. I'm going to load this. Let me show you this tree. All of these pieces have things assigned to them. This is a very large model because this is a very large space. Now, if I wanted to update one element, I don't remember if I was smart enough back then to actually link all these things together appropriately, but keeping all, like this is component 285, like I don't know what that is. It just disappeared. I'm not sure what it was. But by labeling these things all along the way and their subcomponents, it will definitely help whenever you make like a cut list, because it'll assign those names to the individual sheets. And if you need to update something, it will update later on. So labeling, the color swatches that we just turned on all help with organization. So before we start sketching, there are two things that are most important to think about in Fusion 360. First is your design intent. Before you start to draw a sketch, what in the world are you trying to do? Are you trying to conceptualize something when you don't have a piece of paper? Because you don't want your sketch to take 3 times as long as it would be just to go out and build the thing. That's kind of counterproductive. Is it to make a render for somebody? Is it to create a cut list? Because sometimes if you just want to conceptualize something, the actual like dimensions really might be kind of arbitrary. If you're making a cut list, you want those dimensions to match real world materials. So your design intent, like what are you hoping to get out of the thing that we're about to do? If it's a 3D print, you need to think about in 3D printing. If it's woodworking, you need to think about it in woodworking, and we'll get to those differences here in a little bit. So design intent. Second thing is design for change. Even if it is a rough model, even if it is like, well, it's just a bookcase, it's just a big square, always design for change so that if you get plywood from Home Depot and not from Lowe's, they are slightly different. If you make it for a client or you make it for your spouse and they're like, I thought it was going to have 5 drawers and not 4 drawers, boom, you can update one thing and your marriage is saved. So design for change. And I'll show you how we're going to do all of that. So what are we going to make? Who has something that they, I know, Nicole, you mentioned taking a picture of something.
Yeah, I have 2 pictures.
Okay.
But do you want me to share them?
Can you email them to me? Actually, before we do that, let me see. Are we woodworking or are we 3D printing?
We're 3D printing.
Everybody else.
Donovan wanted to do a Lego, FYI.
We can do something like simple like that. That's kind of like a box to kind of get us eased into it.
Yeah. So we'll do a drawer, because a drawer is a box. A drawer is a desk. A drawer is a cabinet. A drawer is in everything. So this is what we did at Workbench Con, and it sets the kind of priority For sketches, it sets the workflow. So we'll do a drawer. Everybody okay with that?
Yes.
Good.
Great.
We're doing it anyway. All right. We have labeled our project, dresser, what have you. So the first thing I'm going to do is I'm going to create a component right there. When you create a component, this fancy box shows up, and this, we are going to call it a drawer.
What if I don't have a box that showed up?
Look on your screen somewhere. It should have popped up. You probably have a large monitor. It may be hidden behind something. It may be moved to the side of something. A box should definitely have shown up. Excuse me.
What?
Did it show up minimized on the right side of your screen?
Yeah, it may do something like this too.
Because mine's
sure
like
you
tied to the
clicked?
right side.
Yeah, I clicked on it and I have the component there. I'm gonna delete it and try again. So
You have a component?
So I clicked
Nope,
where?
the button.
Oh, literally the button. Ha.
Mhm.
I'm so sorry. This is gonna
You
be
good?
Yes.
No, we're learning. We're all learning together. So we're going to label this thing drawer. And check it out. We now have we have a component that is the next tier lower in our organization system from our entire project, right?
Yep.
So within
Yes.
this, it just has an origin because we haven't done anything yet. All we've done is tell the whole world that we have a project, and then within that project, we have a component. So now we're going to create a sketch. The sketch is where you should spend a majority of your time in Fusion 360. Your sketch is where you're going to update things. Your sketch is where you're going to lay out your dimensions. The sketch is where you and your mindset work with Fusion. And I mean that by, if you're a wood turner, right? Say you want to make a candelabra. You work in a cylinder, you take that cylinder and you work downward. If you were a machinist, you take like a cube and you mill away things from that cube. If you're a 3D printer, maybe you have a sketch and then you pull that sketch upward. Like Fusion allows you to sketch something and then take that sketch and make it a 3D object depending on your personality. And I mean that. I'll do a quick example. Let's say I want to create like a can, like a cylinder, but that cylinder has two different shapes, like a barbell or like a Lego train wheel. So there's a bunch of different ways to do it. And SketchUp, or not SketchUp, damn. Fusion just updated, so it doesn't snap to things like I want it to, and I don't know why it just made a circle. We're gonna go up here. Once you create a sketch, your toolbar changes. You have a bunch of different shapes that you can create. Lines, rectangles, there are different types of rectangles. My favorite is the center rectangle. I have made this a hotkey, so I hit Shift R, and that gives me a center rectangle. I like working from the origin out because it gives me a central point that I know that I can always come back to. So that's a habit of mine. You can do arcs, polygons, all this stuff here. You can mirror an object. You can create circles, you can create rectangles, you can measure things. Oh, one thing I forgot to do. What was the second thing that I mentioned was the best thing about Fusion 360, or that you have to consider when working in Fusion 360?
To
Design
scale?
intent, design for change.
Yes.
So we're gonna go back. So hit your back button, Control Z, whatever, Command Z. We're gonna create parameters first.
How did you get to there?
This little f of x, this little function. So
okay.
I got out of the sketch, go to modify. It's down here. Again, right click on those three bars and pin that to your toolbar.
Yes.
So we're gonna make ourselves parameters because like an Excel spreadsheet, everything that you're gonna make in 3 dimensions has a length, has a width, has a height. All those things are subject to change, so we are gonna make them a parameter. So first is going to be, this seems really kind of monotonous and tedious, but by instilling this early, you will help yourself down the line, I promise you. So we're gonna do drawer width. Everybody with me?
Yes.
And our drawer is well, I don't know, 12 inches wide, which we can change to metric if you really want to. And then we're going to do drawer height. Drawer height can be 6 inches. We can update all of these. And then the drawer, I guess, depth, because it's a drawer. Deep it goes. I don't know, 8, oops. We'll do, somebody throw out an expression. How deep should a drawer be?
6 inches.
That's a shallow drawer, for sure. 6 inches.
It would help if my mic wasn't muted.
Yeah. Let's do the drawer different than the height.
8 inches.
What's cool about this is let's make the depth a function of the width, because we can do that because we're smart and this is a computer. So if you're designing furniture, does anybody know about the golden ratio? Has anybody heard that before?
Yeah.
So the golden ratio appears in space when you're doing furniture design. Something should be, I think it's 1.61 is the magic number, the golden ratio. So if you're designing like a cabinet, it's a proportion of the length and height. So if we want to do this, let's just say the drawer depth is the drawer width. And then I'm going to use the asterisk times 1.61. Like, neato. So as the drawer width increases, the drawer depth will increase. So you can create functions all day. And so let's say the drawer height, I don't want it to be 6 inches. I want it to be 12.5 millimeters. Like, okay, you can do that too. It's really great.
I was thinking of drawer height. 6 inches for drawer depth is retarded.
It's a really skinny drawer. So let's do, this was just to show you that you can mix units, you can create functions that are derivative of other things, because every time you draw a line, every time you make a shape, you want to ask yourself, like, what is this connected to? Because again, like an Excel spreadsheet, you don't want to get all the way to the end and realize you typed in a 5 instead of going equals 2 plus 3. So the drawer depth is whatever, 18 inches. So what are we making this drawer out of?
Plywood. Yeah.
Okay. So we're going to do plywood thickness. Let's do plywood thickness 1, because there's lots of different plywood thicknesses. Say you got Baltic birch plywood that comes in millimeters, or you get the stuff at Home Depot that's not quite 3/4 of an inch. But for our purposes here, let's say we're going to make this out of 1/2 inch plywood. You can either type in half like that. You can type in half like that. You can type in 6 3/16 like that if you want. Fusion's cool. So let's just say this is 1/2 inch plywood. Ready? So let's make a drawer. Is everybody with me so far?
Yes.
Yep.
If you're not, please say I'm not, because I can't see you.
I do have a question. Your
Yes, sir.
values are displayed as fractions, and your units defaulted to imperial.
You can change that.
Is that just in a setting, buried in a setting somewhere?
Yep, right here in
Okay.
document settings. I have mine in inches. You can change this to millimeters, meters, feet, whatever you want as your default. Whenever I'm designing something from scratch, that's not necessarily woodworking, I will work in millimeters. But if I'm going to be making something out of wood, the wood at my hardwood store is measured in inches, so I use what will be reflected in real life. Now, most of the time, if you pick up your iPhone, you pick up a book, all that stuff is originally designed in millimeters. So I will try to play it as it lies, right? So you want Fusion in your design intent, you want your Fusion model to mimic real life. Because if you make a bookcase and the edges of that bookcase are like 3 inches thick, like what kind of material are you going to make that out of? You're not going to go mine it in Minecraft. You're going to go to the store, and the 2x4 is actually 1.5 inches by 3.5 inches. So make your model mimic real life so that it can be a physical representation of the thing you're going to make, or you just like designing stuff on a computer and then you don't get to have it in the real world.
Hey, Josh,
Gotcha.
if I wanted to build an arc, do they have qubits as units?
You can set qubits as a function. but I think the length of a man's arm is different. So you'll definitely want to make a qubit a function because you have to measure the individual man's arm, and then you can update it, and then your arc will be updated based on the person who is actually building it.
Right on.
So I have a
Fellas.
question.
Yes, ma'am.
Okay. So something that kind of goes back to the last question. When I'm looking at my parameters, I see my expressions are all labeled in inches, but when I see my values, it's like 12.00 or my 0.5 is 0.5. Yours on the screen is literally
Right.
showing a half.
Oh.
No,
I
but
don't
that's
know why.
different. Mine is, I have that set up correctly.
That was part of my question as well.
Oh. I have
I
no
think
idea
that
why.
probably links back to your personal
Let's go up here.
preferences.
So
Yeah.
go up in the top right under your name. Go to preferences. Let's figure this out.
What?
So
Oh,
I have, okay, this is good anyway. Your default modeling orientation, I have my Z up because
Yep.
I'm a 3D printer. And whenever you start building from the floor up, if you go to export your STL, it's going to lay on its side if it's not Z up. So you can go ahead and change that to Z up. Bless you.
I tried to mute. I couldn't get it in time.
It's all right. We're here to help. Units. This is what I have. If you want to make yours look like mine, then great. I hide
that's
trailing
good.
zeros.
Under foot and inch display format, mine
Yeah.
says decimal and yours says fractional. So.
Yeah, so it's just changing to fractional. Okay, thank you, Josh.
You're welcome. Okay, let's go back to parameters real quick. So again, I tell Bob, if you have like a notebook and you want to make a desk or a cabinet to fit a space in your house, so you take out your tape measure, you measure the room, right? You measure a space. If you measure a space, it needs to be a parameter because you probably didn't measure it that well. Or if you need to change it, you can update it. So anything you have written down in a notebook, if you're trying to recreate something and you measure it, make it a parameter. The more parameters you have, the safer it's going to be down the line. And it also allows you to think through what you're going to make because our drawer is a three-dimensional object. It has a width of the face. It needs to fit inside a space in our desk. So it has height, it has a depth. And I'm going to make it out of plywood, so the plywood has a thickness. Excuse me. We're going to come back later on, and we're going to be adding a different type of plywood. So I'm going to show you that this can change, and you can add to this as your model adapts. So we have our parameters. Let's go ahead and draw some stuff, right? So we're going to go up here to create a sketch. Everybody see my icon up here in the top left? Create a sketch. And now you can orient around. I'm using a trackpad on a Mac. So if you hold Shift and the middle button on your mouse, you should be able to orient around. Is that correct?
Oh, yeah. Mm-hmm.
Yes.
You can spinny, right? To move, I think if
Very
you
disorientating.
if you hold right click, you should be able to drag it around. Is that correct?
No. Well, not
Try
from the
holding both buttons at the same time without holding Shift.
Nope.
Its middle mouse button moves it around.
Okay.
Oh, yep. There you go.
And then to zoom on a trackpad, you spread your fingers apart. Maybe that's the wheel in the middle, forward and back.
Yep.
Okay. So with this box, we are choosing the plane. You can see the blue line is a Z up. So this is the floor. You have a cube over here in the top right, and it lets you know because you should change it to Z up, right? So you have the front, you have the right, you have the top. Those are pretty arbitrary, but it really does help you, especially when you're starting out, to kind of keep yourself grounded because there is no floor. So we are going to start building this upward. But again, that all depends on your mindset. I do things in 3D printing, so I think of it as a build plate and I go upward. If you want to go build your drawer from the drawer front and you want to build it into the cabinet, that's completely up to you. So I'm going to start on the floor, and you should have moved. It updated, and now it doesn't move to the thing. It doesn't move flat, so I'm going to figure out how to do that. So I'm looking straight down on the top. Does everybody understand? Does everybody see what I'm seeing?
Yes.
Yeah.
If you don't, please say you don't. Please don't feel scared because I want to help you. Okay.
Hang on one second. Sorry. My drawer is gone.
The drawer is gone.
Yeah. The
This component.
my component is gone. I can remake it real quick, but it was gone for a second there.
You have the fusion test up at the top, like you have up here in the top left.
Yeah. I mean
The first
now
order?
it looks good. Now I can but I just had to recreate this drawer one.
Interesting. So there's a couple ways of drawing a rectangle, and I'm going to show you the one, and I'm going to show you what I do. Okay, so you can click on the rectangle button. You can create its starting point. And when you create a starting point, it is also creating what's called a constraint. So if you look up here at the top, there's all these red icons called constraints. These are lockable relationships that you can create between sketches. When you start a sketch, you are automatically creating what's called a coincident constraint, which is this guy, meaning this will forever be locked at this point. So by doing that, you click and then you drag out. If you click again, it will stop. But again, this is if we were going to be typing in 4, 7 in an Excel spreadsheet. We don't want to do that. This is where we're going to use our variables. But by creating a rectangle that pivots from the corner like that, if you have a CNC mindset where you're like, well, I want this to be my home position, like that could make sense for you. I like to keep the origin in the dead nuts center of my model because I can mirror stuff. So I don't actually draw a rectangle from the corner out. I draw it from the center. So I'm going to hit escape because I didn't actually do that. Go up here to create rectangle, center point rectangle. And again, if you right click on that, you can change keyboard shortcut, because if you just hit R, it will create that 2-point rectangle. And it won't let me get rid of that R. It won't let me unassign that. So I had to create a new one. So I assigned Shift R, which gives me a center point rectangle. So when you do that, this is like if you're a Photoshop or Illustrator type person and you work from the center out. So this is where I like to work, because now everything is, all of the X and the Y are mirroring each other. So I'm not going to click down. I'm going to create this shape using our parameters. So this is going to be the footprint of our drawer, because we already know the size. We theoretically measured the space. I'm going to start typing. See how where the blue is then 3 15/16 there on the left? So wherever that blue is where you're going to start typing. So D, I can already start, and it already gives me the drop down. So if I'm looking down on this drawer, this dimension is the drawer, actually the drawer depth. And just updated. So you're going to zoom out because it will, the size is relative. Then I'm going to hit Tab, and it goes over to the other dimension. Now, what was this? What should you type here?
The drawer width.
Exactamundo. This is the drawer width. So once you have the drawer depth, and when you assign a variable, you hit enter and you can still type. So if you want to, again, we can make this a function. So this is the drawer depth plus 300, 5, 9, 6, 2, 5, 7, 8, 9, whatever you want. And it'll update as you want.
Josh,
Yes.
I missed the starting from the center.
Starting from the center, yep.
Yeah.
So the rectangle that's pinned in the toolbar is
Yeah.
not starting from a center.
Gotcha.
That is the center rectangle.
Okay.
And if you right click on it, you can either pin that to the toolbar yourself, I use it so frequently that I created my own keyboard shortcut and I assigned Shift R.
I gotcha.
Yeah. So anything that you find yourself using frequently, make your life easier and assign some hotkeys. So this is the footprint of our drawer, right? Everybody with me? You spin it around, it's flat. It's the suckiest drawer I've ever seen in my life. It doesn't do anything. So we got to make it. So how are we going to make a drawer? We need walls, right? So we're going to go back over here to our library, or not to our library, but to our tree, and make sure that we're organized first. So now we create a sketch. Now we have a little sketches folder. And then there's sketch number 1. I'm going to rename this. I know, again, this is tedious, but we're going through every single motion so I can show you how to do this. This is the drawer footprint. So if I can spell it right. So if you need to change something, or if you need to turn it off, you can do that right there. You can turn off all the sketches. You can do that right there. So these are the outermost dimensions of the drawer. And notice that all of these lines are black, right? All right, is everybody's square filled with or have black outlines?
Yes.
If you do, say yes, please.
Yes.
Yeah.
All right. So I'm going to hit R for rectangle, and I'm going to just draw some arbitrary square, right? This one is not. All of these are blue. What the heck? That means that this square is not fully defined. Not fully defined, meaning it does not have a dedicated length or a dedicated width. It is variable right now. Like it is just, it stopped right where I told it to stop. So I can drag it, I can move it. I started it in this random point in space. So I can move it all day. It's not fully defined. If I were to give this a length and give it a width, it will turn black. Okay? That's not super important, but that's the difference between a blue and a black square. So now we're going to build the walls to our box, and then we're going to pull them upward. So you can move it if you want to. I'm going to create a rectangle. But because I'm going to make a wall, I'm actually going to start here in the corner. So I'm going to use the rectangle that's up there at the top. I'm going to start there, and I'm going to drag it down. Now, lazy person could say, well, I could just snap it down there because it's already on this thing. That's true, but we're going to use variables. So this is the drawer depth. I'm going to tab over. You could type in 0.75. You could type in 3-4 because my plywood is 3/4 of an inch, or you can type in 0.5. That doesn't update. That's not variable. So we're going to use our variables. This is because we're making out of plywood, like you told me earlier. Plywood thickness, 1/2 inch. Like it says function 1/2 inch. So if you need to change one of these, you can double click on this measurement box and you can change it. But because it's a variable, we can change it back in the variables menu, which we're going to do here in a little while. I'm going to show you the magic. So we're going to keep doing that until we go every single one of these. You can do a mirror tool, but again, I'm going to show you the longer way. This is the drawer depth. I want everybody to make all 4 walls out of the plywood thickness that we assigned earlier. Okay, and let me know if you have any questions. If you create a spot here in the corner, it's easiest if you create as many things that touch that corner right there. We're going to overlap these squares. But you're going to think, in woodworking, if I want to do butt joints, they don't overlap. We're going to get to that. Make all these overlap, and I'm going to show you why. Or width. Put it down here. Wood. Width. Now, when your screen looks like my screen, let me know. I'm going to zoom in. We created all 4 walls that are overlapping using the parameters, using variables, not typing in any amounts. All these should be functions because we're smart people who know how to use computers. We're going to make the robots work for us.
Okay.
I don't know how many people are watching right now because, again, I can't see any of you. But whenever you're done, just say done. And if I hear
Done.
enough,
Done.
Donovan's shooting the mic or the camera, so I think he's done.
Okay.
Almost there. I had to redo one thing because I'm an idiot.
That's all right. We can redo as many things as we want to. And speaking of redoing, you look down here on the bottom, we have something on our timeline. We created a sketch. So if you move this little cursor back, like we just went back in time. And the dopest thing with the coloring that we did is right now, this is the active component. We're going to have more components in a minute. And when you have multiple ones, it's way easier to visualize where you're drawing and what you're drawing when you have this coloration turned on, and your elements down here on the timeline are now color coded.
While we're waiting
So-
for people to get their stuff done, can I ask a cursor question?
Yes, ma'am.
So is there an easy way to like not have to hit the pan at the bottom with the little hand to move around? Like,
Yeah,
is there
you
like
can use keys. Yep. So to move around, I hold Shift and I gotta remember how to do this. I use a magic mouse, which is terrible, and I use a trackpad, which is also terrible.
oh
So hold
god.
Shift and hold the middle button.
Oh.
I'm guessing. And
You're
then
right.
to move it, to just like move it around in space,
Up in the top.
you do something else. I touch the trackpad with 2 fingers and it'll move it.
Well, if you hit the little guy in the corner, that little animation, that will center you again.
Yep.
Okay, cool. Thank you.
Okay, so I
Now,
got
if
a
you
question.
hold, yes.
Sorry.
No, go ahead.
When you're drawing the top and the bottom there, what did you put in? Because you put in drawer width, that's going to be a 1/2 inch short. It comes up on mine as a 1/2 inch short. It doesn't overlap. Did you overlap it manually? I missed that part again.
No, it shouldn't be, because the very first box we did was drawer width.
Uh-huh.
So if you start in this corner, and then this rectangle that you're doing right here is drawer width, it should match up to the outside dimensions.
Okay. Mine doesn't for some reason.
Did you set your parameter correctly for the right measurement?
Well, if you use the same parameter,
Oh,
I used the same one, but
If you want, you can share your screen. You can see what you're looking at.
all right, let me do that real quick because I'm honestly lost right now.
do you have these measurements? Do you have little measurement windows?
Yeah.
Okay. So the very first one you had was for the big rectangle, correct? And this is where also we're splitting this up into 2 sketches would also be really, really beneficial, which we probably should have done. There is a rule that says like 1 element to 1 sketch, but that gets like super monotonous. We will get there in a little while. So like setting the footprint as 1 sketch, creating another sketch on top of that for the walls, probably be a decent idea.
Mine says 1/2 and then 12 and then 1/2, just like yours, but on the right side, mine has an extra space that is a gap.
Where did you start that rectangle?
Right there on the very outside.
Right here?
Yep. And I put in thickness for the one and then drawer width for the other. Here, let me show you real quick.
Yeah. So you have 19, 15, 16s. Okay. Huh. So then your original box. Okay, do this. Hit I. Okay. Go from the outermost corners, and there should be like a little ball that appears. Yep. Click 1, and then go to the other outermost corner directly across from it, and hit it. And what's it say? See, that says 13. So your.
I know what it is. The right side thickness of plywood is on the outside of the box and not on the inside of the box.
Ah.
Or maybe it's both of them even.
Yeah, that's right. Yep. You got to go inward.
Oh my God.
Good call.
All right. So
Because you can see that
the
dashed cross lines, the dashed lines in the middle. When you draw a rectangle, it'll connect all the corners by those construction lines. Start there and go inward.
Okay. All right. I can stop sharing. I'll fix that real quick.
Okay.
Donovan was having an issue renaming.
Renaming?
Yeah.
So
he's gone now, but
if you just kind of like kind of slow double tap. You can
Yeah,
rename it.
that's what I told him. He said it wasn't working, so I had to wait for him to come back.
Okay. Back to color coding. So right now, this component is assigned this yellow color. And if we go back up here to Fusion Test, and if we make the entire project active, that's what that means whenever you click that little bubble, you can see everything that we've done so far. And when you color code like we did, if you go to your project and you can see everything that you've made, all of your components at once. The library being color coded is really nice because you can see what you did to the individual component. And when you activate a component, it will get rid of all of the like processes that don't belong to it. So you can kind of filter stuff. It's pretty nice. And when you finally have like a big piece, your finalized drawer, room, what have you, you can go to inspect component color toggling, or you can hit Shift N, and then it will assign all these colors to the individual components. So that's really good if you want to create woodworking plans and you have, I don't know, multiple panels. It just allows you to kind of visualize it better. So that was a little trick somebody showed me. Now, right now, I got out of that sketch because I accidentally hit end sketch or finish sketch or whatever. If you want to get in here and edit this sketch, because we named it, you can either double click it or you can
Okay, I'll cut back up, FYI.
Okay, so everybody's right here. We are going to make this an actual box, but there are some questions because our design intent, we want to make this in real life. So there are some questions that we're going to ask ourselves. First off, what kind of joints are you going to be using for this box? Are you going to use pocket screws? Because if you use pocket screws, it means you're going to have a butt joint. And this means that like this rectangle here may be longer than that rectangle there. If we're going to be making a drawer, if you're going to be making finger joints, right? You want measurements. You need to know the actual length and width so that you can make one cut. You don't screw it up. So let's say we're going to make finger joints. So we need both of these boards to be their full length. And then we can go back and do, I'll show you how to make them butt joints and stuff later. So we're going to, because we're woodworking, we want these to be separate entities. Now, if I was 3D printing, all four of these walls could just be one big unified like moat. But we don't want that right now. So what we're going to do to turn this two-dimensional object into a three-dimensional object is we're going to finish the sketch. And we're going to go over here to extrude, or you can hit E, which is the hotkey that Fusion assigns to extrude. And we're going to, again, because this is woodworking, we have to do this part in a very specific way. So follow along with me. Okay? I'm going to select, excuse me, because these are overlapping, it creates its own little area. So we're going to do the front and we're going to do the back. In Fusion, if you select things that are adjacent to each other and you extrude them, it's going to extrude them all as one big piece. And so because we're doing an entire front face, that's fine. But if we were to do this corner and the adjacent wall, it would make one big L, and we don't want that. So again, we can extrude this up. I can type in 6 inches if I want to, but I don't want to do that because I'm not a dum-dum. I'm going to type in floor height because we did this already, right? Bam. Now, when you hit enter, your sketch disappears. That they think that you're finished because if you do the one sketch for one element, theoretically you should be done with that sketch, but we're not. So turn your sketch back on and there's your stuff. But when you see in our tree over here, we have a new friend that just showed up. We have bodies. Everybody say hi, bodies.
Hi, buddies.
He looks sketchy.
Now we have these.
Bodies.
Does everybody see what I'm seeing? Say if you don't, please let me know.
I don't see bodies.
I have bodies, but it's outside of my drawer. It's just under the Fusion Test tab.
That's because
See bodies.
your drawer was not the active component. Your Fusion test must have been the active component. So what you can do is in the bodies folder that's like, it's over here, right?
Yeah.
Where my cursor is.
Yeah.
Select both of those bodies and then drag them down to the drawer component. Did that work?
No.
You may need to create another body, and then a bodies folder will appear, and then you can drag them down to that bodies folder. But this is a good point. Like, imagine that you're working in a space, the fusion in the whole project, and now you created a component, but you're theoretically still standing out here in the project. And so you're creating stuff out there, not inside the drawer component where you really need it to be.
I see.
So to do that, again, we need to select it, and it'll become the active component.
Okay.
Now, someone else said something else. You didn't see bodies at all?
I do, but it's not in the drawer component.
Is it up here?
Yeah.
Okay, same thing. So you must have had the entire project activated, but because we created a component, and when you create a new component, there's a little radial button right here that says activate.
Yeah.
Make sure that little guy's clicked, because we're going to make some more. So just make sure in the future this little box is checked, and it should do it forever. And that way you can have all of your stuff where it should be, and not in like the entire primary like project folder. It's in its little organization where it needs to be.
Okay.
So I'm going to name these bodies. So they should just be body 1 and body 2, correct? Regardless of where they are in your organization tree, it should just say body 1, body 2, right?
Yep.
Okay, so let's name them, because everybody deserves a name. So this is front wall. The other one is back wall. And okay, not letters. Front wall, back wall. Now we're going to do the side walls. So make sure that drawer is activated. Click the little bubble next to it. Okay.
Yep.
And we're going to hide these 2 walls. We kind of want them out of the way because we're going to be using the sketch again, and they're kind of sitting on top of the sketch, so we want them just to go away real quick. So we're going to hit their eyeballs, and we're making them go away. So is everybody's drawer 1 the active component?
Yes.
Yes.
All right. We're going to go up here or hit E or go up to the extrude button. Now we're going to do the other walls. We're going to make sure we get the corners too, because we want these boards to go all the way to the corners for this example. And again, I'm not going to type.
Oh, okay. All right. It's good. We're good. We're good.
You can drag it, you can type it, or you can tell it. This is drawer height. We're going to hit enter again, and the sketch should go, well, actually it didn't go away. So now, under drawer, you should have a little bodies folder, correct?
Yes.
For everybody else whose bodies are up here in the top fusion thing, select front wall and back wall and drag them into that bodies folder.
Yeah, that worked.
Nicole, you good to go?
I'm getting there. I'm just selecting everything. Drawer height. Enter. Yep, we're all good.
All right, so we give everybody a name. This is the left wall. Enter. Slow double tap. The right wall. And we can turn them all back on. We can pan around and look at the dope perimeter wall we have just made.
So fancy.
That cannot exist in real life because this is a big dumb 3D model. And the robots will only do what you tell it to. And so right now we created a scenario that cannot exist in real life. This is 2 pieces of matter existing in the same space. That can't happen. So if you're going to create a finger boxed joint or something with dovetails, you have what you need. You need to know how long this board. You're going to hit I for measure. You can measure this entire edge right here. And it'll tell you that's 18 inches long. You can hit escape and hit I again and go to this other side. It's 12 inches long. Or you can hit this one and then hit the other one, and it'll give you both of those dimensions and the angle between them. So you can write this down on a piece of paper. You go, I need to go to the miter saw, and I need to cut 2 pieces that are 12 inches long, 2 pieces that are 18 inches long, and then cut a whole bunch of finger joints, and I will have this created out of 1/2-inch plywood. Hooray.
Yay.
But let's make this mimic real life, and this is a drawer, so let's use box joints. So we're going to do a butt joint. But because this wall and this wall are occupying the same space, we don't want that. We're going to give it a bottom here in a minute. We're just going to deal with the walls first. So we're going to use another tool called the combine tool. Now, the combine tool, you're like, well, that's a stupid name. I don't want to make this wall and this wall together. You told me I'm not going to do that. The combine tool can do a couple things. It can join stuff, it can cut it, or it can keep the intersection of that thing. So they are labeled the target body and the tool body. The target body is the thing that will be affected by the tool. Okay? So the order is important. And because we're making a drawer, I want the face, this front face here, I want to keep that a full length. So I'm going to remove this full length from the sides. Does that make sense?
Yes.
So that this sidewall will only butt up to the edge, where right now it does not. So my target body, which you can only select one at a time, will be that wall.
That's
tool
backwards the way I would think it would be.
Right. So the tool, I'm going to use this front face, not join, cut. Now, one thing is very important. Keep tools. Keep tools. Or it will
Mine
get rid
did
of
the
that wall.
opposite.
So this is really handy if you create an item, like if you were to create or model something you have in space. Like I created a phone dock. So I modeled my iPhone. I made like a rectangle, and then I subtracted my iPhone from that rectangle. I made a perfect little iPhone cozy. So if you want to create a 3D model and then remove it, like if you're going to make it an injection mold or a perfect little holder, this is a good tool. So now I'm going to keep the tools. I'm going to hit OK. And I'm
Josh.
done. Yes.
Mine did the opposite. Mine is taking the face, is cutting into the face with the sidewall.
Then reverse your order. I'm going to hit Control Z. I'm going to undo what I just did. So I'm going to combine my target. Which one do I want cut? I want the sidewall cut.
Okay.
And the tool I'm going to use to cut it is this front. And actually, let's just go ahead and do the back too. Boom. You can create more than one tool, but you can only create one thing to be cut. But you can select everything you want
to cut
it with.
Okay.
Does that make sense?
Yep. I'm tracking
Okay,
now.
we're going to cut, and we're going to keep the tools, because if we don't, then the front and the back are going to go away. So we're going to hit OK. And so you can see the difference between this side. These two are overlapping, like if you were going to do finger joints or dovetails. These two are not, like you're going to do butt joints. So let's do the same thing to this other wall. Use a combine tool. This is my target. I want to cut with this. I want to cut with that. Cha-chow. I want to make sure my tools are kept. I'm going to okie dokie. So, is everybody with me?
Yes.
Yes.
Following along. How is this with everybody? Is this okay? We're doing all right?
Good.
All right,
I have
we're gonna
quite a
hit
box.
I to measure. And now if you select that edge, it's 17 inches. Because we cut out a ½ inch on either side.
Donovan says he's got a trapezoid.
How?
Okay, well this is
my
the
length
importance
is
of using
different, but
parameters.
whatever.
I don't know how he has a trapezoid.
Well, my box didn't connect earlier, so.
He just voiced to the camera, I don't either.
Don, if you want to share your screen for a second, we can take a peek.
Yeah.
But
I'm interested now. You got my interest peaked.
Honestly, mine kind of
in the
looks
bottom
like
left corner, there should be a share screen option.
It's a little monitor looking icon.
Actually,
It's not letting you share?
No,
Jitsi does not like Donovan.
No.
I mean, the little icon button in the bottom left hand of the actual Jitsi screen. There we go.
oh, I think that's mine. Sorry,
No,
I was playing around.
good job, Seth. That is a fine looking wall. Gold star.
Share button is grayed out. He's in the chat.
Man, I don't know why.
Wes, did you change his permissions?
I did not.
Okay, I have no clue, but he and I can talk about that. Whoa. There we go.
Donovan, are you using like Internet Explorer or something weird, or Mozilla?
Microsoft Edge.
Yeah.
So, as a drawer, this still kind of sucks because your stuff would fall out. So we need a bottom.
It's normal.
Right? So, just like making a drawer in real life, there's many ways to make a drawer bottom. You can make one and just attach it flush to all 4 of the walls if you want. You can inset it inside here. You can create dados and you can make one that floats. We're going to do all of those. But first, since we're really cheap and 1/2-inch plywood's kind of expensive, we're going to use Luan or like 1/4-inch material for the drawer bottom. So we're going to go up here.
The YouTube comments are going to be horrible on that.
That's fine. We're going to create another parameter. Okay. Actually, we're going to create a couple. So everybody go back to the parameters. Is everybody with me?
Yep.
All right, we're going to create a new one. This one is bottom thickness.
What a great
Thickness
parameter.
with 2 C's.
Not like it sounds like you said.
And this will be a 1/4 inch. Now, I also want to create a dado. Now, the dados that we use, you can create a 1/4-inch dado if you wanted to make like a rabbit on the bottom. Does everybody know what a rabbit is? If you have a rabbiting bit, you run it along the thing and it creates like a 1/4, usually a 1/4-inch channel.
So
we're
is that like a rebate?
But for this dado, we're going to use
Sorry.
half the thickness of our original plywood material. So we're going to use plywood thickness divided by 2. I get that?
Is there a reason you did
Yes.
that? Can you explain that?
Yeah. So when you're woodworking, do you know what a dado? Does everybody know what a
Yes.
dado is first?
Yeah.
Okay. So a dado, we're going to cut a channel into the side wall. We don't want to cut too deep into that wall so that it weakens the structural integrity of the wall, but we also don't want to cut too short so if we apply a downward pressure to the bottom, it could potentially pop out.
Okay, I got it.
So that's why we're going to cut halfway through the thickness of the wall of our drawer.
Okay.
And we're setting that here because I just don't want to put a 1/4 inch because if we increase the thickness of that plywood, like we're going to here in a minute to show you the beauty of this program, I want it to update. Everything is tied back to the lowest common denominator, like a single point. Everybody should be drawn to a single point measurement. Excuse me. So let's pan this around and we're going to look at the bottom of this box. We're going to click on the bottom of the cube. There's the bottom. We're still working on our active component is the drawer right now. Our bodies, we have 1, 2, 3, 4 of them. You can collapse that menu. In our sketch, we have the drawer footprint, which in theory, we should have had the drawer footprint and we should have had another one for the walls. But right now we're going to create a new sketch for the drawer bottom. So we go up to the top, create new sketch. And now our origin plane, we can create a sketch back on the floor because we're looking on the bottom. So it would have been, these are the bottom edges. You can create a sketch just on this one little wall or just on this little corner of a wall. On any face, any planar face, you can create a sketch. So because I know that all these were actually done on the floor, I'm just going to put the floor. There you go. So it shows that the sketch is now on the bottom of my box because this is actually the same plane and we went up. So now we're just going to go on the underside of that plane, if that makes any sense. Everybody following me?
I did not understand. So you told it to sketch on the floor. I missed how we're doing that.
Okay, I will go back to Command Z. So I'm going to create a new sketch. So here's my origin point, right? It popped up. Which one of these planes do I want to operate on? You can create one on any face you want, but I want to do this on the bottom. So on the flat plane, let me see. Let's get rid of all the bodies right now. Whoa. So this is where, this was the top, right? This is where we were originally working. I want to create it on that same plane. But if you click on a sketch, sometimes it'll take you back into like editing that sketch. So just beware, sometimes that kind of happens. So just to ensure and to visualize that I'm going to be drawing on the bottom of it, I'm just going to go like that. Oop, hold on. I'm just going to go like that. Same thing. So now I'm just drawing on the underside. I could have done that right here, but just to show you that we're doing it on the bottom, I'm just going to do it under here. Okay, same plane. Same exact plane.
Gotcha.
Top of it, bottom of it. I can go up this way, or I can go minus that way. Same exact plane. Okay, so I'm going to click on the cube so I can get a nice flat face. We can turn our bodies back on if you really want to. So one thing that you can do, since we're now drawing, is you can redraw a rectangle if you want, because we don't have a variable for this inner rectangle, right? All we have is a variable for the outer dimensions. The drawer width and the drawer height are all these outer boxes. So how do we assign a shape based on something that is based on a variable? Wow, that was a weird question. What we can do is you can project. Okay, so project is in the create menu, buried down in here. This project, right click on those three dots and pin that bad boy to the toolbar. Once you've done that, I'm going to explain what project means.
I have done it.
All right.
I've also accomplished it.
I have also done it.
Imagine that all of us are standing in an orderly file straight line waiting to get something really, really cool. Okay, Nicole standing
Are we
there.
6 feet apart?
Nope, I'm not. Seth is standing in front of her, Corey is standing in front of Seth, and so on and so on and so on. Let's say I am looking at Corey, Seth is behind him, Nicole is behind him. Now let's say I want to draw Nicole, but I can't see Nicole because there's people in front of him. There's stuff. There are drawing layers. There are dimensions of things from where I am standing to where Nicole is. I can project a silhouette of Nicole or whatever shape that we happen to do, and it will project onto the plane that I am currently drawing on. And it will update. If Nicole were to lift her arm, her projection theoretically would lift her arm. And so you can project what is back in the back or a shape that you can't necessarily snap to because it's not on the plane that you're drawing on. Does everybody get me?
Yes.
So right now I can see all these boxes, right? I can see it. If I want to click the, what is it about? But sometimes, if you were to create another sketch on a different plane, you would not be able to snap to these, but I created it on the same plane that this one was on. Anyway, the project tool allows
that would be
you,
what it's for, though.
yes, allows you to
nice.
make a silhouette of things so that you can draw it on our current, and then hit okay. It's over here in a little dialog box. It's okay. So it comes up with little purple lines. So that way I can get rid of those bodies and get rid of that sketch, and I have a projection of what was behind the plane I'm currently working on. So this is really helpful if you're creating like a complex part, or let's say a lightsaber. I'm going to look up the bottom of a lightsaber. I want to create a hole all the way through the middle of that lightsaber, but I don't know where the activator switch, or I'm not sure, this hole needs to be 1 inch and the outer needs to be 1.25 inches. You can project all of those shapes on a plane that you are currently working on, and it'll show up here as little rings or boxes or whatever. And that way you can know that if I want to create a rectangle, this is my outer limit, even though I can't necessarily see the outer limit because it's dimensionally far away from me.
Gotcha.
Does that make any sense?
Yes.
Okay, I got it now.
So,
Good.
because we want to make a bottom, now I can just draw a rectangle and it creates that coincident joint. And because I projected those walls, that rectangle, which starts there, has a locked joint, ends there, has a locked joint. Now, if the walls change shape, change length, width, thickness, my projection will change length, width, thickness. Therefore, this rectangle, which I just assigned to snap right there and to snap down there, will update length and width. Does everybody understand that?
So good.
Yeah.
Projections are like an active silhouette. So if you're drawing against an active silhouette, everything will update with it. So because we want to make an inset box, that's why we only did, we'll get rid of these bodies really fast. That's why we only did this rectangle. Now we can extrude that rectangle. Let's hit E for extrude, which will stop the sketch, go back into the solid environment, click it, and we're going to drag it up, right? Oh, we got to turn the bodies back on. Sorry. So you can make it come out of the bottom if you want with a negative number. We can make it go all the way to the sky. How thick does this bottom need to be?
The thickness of the
plywood.
bottom of the
Or
whatever we called it.
That's right. We gave it a parameter. So this is the bottom. I'm going to start and boom, bottom thickness. Now, here's another piece that's important. Actually, probably should have made the bottom its own component. That's weird. Okay, hold on. Everybody back out real quick. Back out. Back out of this sketch. Back out of the projection. Back,
Okay.
Back. Back. I'm just hitting, you can hit the back arrow up here, or you can hit Control Z.
Up where?
Right here, a little back arrow.
Okay. Okay. I see. I see.
Okay, yeah. So we created, make sure we didn't go too far back. We have bottom thickness and we have dado. Okay,
Is that the
we're going to create another sketch. But if you create a sketch with the drawer being the active component, you'll create a subcomponent of the drawer, which is fine. We can do that. It's not a big deal. The bottom technically is a subcomponent of the drawer, or you could create another component all the way up here in your whole project. It's really up to you. So I'm actually going to make one up here just to visualize what I'm talking about. So I'm going to create a new component. Make sure the activate, we're going to name it or welcome. Hang on. Holy crap, what happened?
We got ghosted.
Right? That's a good thing. Because the drawer bottom is the active component. These other things allow you to see in relationship to what you're doing, but we're really working right here. And this is a way to visualize that. So now we have, I'm going to collapse the sketches for the other drawer. Actually, I'm going to collapse the entire drawer altogether. And we're only going to focus on the drawer bottom. So now we're going to flip the drawer to the bottom of it. Going to create a sketch. Now make sure your drawer bottom is the activated component. Create a sketch. I'm going to create a sketch on the bottom. Okay, everybody with
But
me?
now we got to
Everybody-
do the projections again, right?
Now this is where projections shine. So if we try to hit our center rectangle, for me it's Shift R. I'm going to start here in the same origin point. Like you can do that, but if I do that, because it's not projected, this bottom will not update. So we're going to project. Since we pinned it up here to the toolbar, we're going to project those walls so that if the walls update, which are a variable, then my stuff now will update too. We're tying everything back to a changeable element. Okay. Now, select a rectangle from that corner to that corner. Everybody with me?
Yes.
Oh yeah.
You did just the inside. Yeah. Okay.
Yep, just the inside. You can hit E for extrude, or you can click the button. Select the face you want to extrude. This is bottom thickness. And now it just says new body, where before it wanted you to join, because Fusion wants everything to be one big solid 3D printed thing, not individual woodworking type panels. If you're in a component and if there are two bodies that are next to each other, like if you were to try to do this, if a body is touching a body, especially if you want to extrude it, it's going to want to try to join it together. And you have to go over here and go, no, just make it a new body. But since we're in a new component, that's not a problem. They're not touching each other. They are completely independent little elements.
I'll never
See
remember that.
So
My box
now,
looks like your box.
yeah, here.
Me too.
So now you can go back up here and activate the fusion test. You can still see this silhouette. It's because the sketch is still on. You can turn the sketch off on both of them. Somebody is still on. There it is. I have a box, which you can take measurements again. But again, for woodworking plans, is this a good idea? Is this a very strong box?
No, I mean, not really.
Not really, right? Because if you were to
Right.
put something in here, this is not attached it's not very thick. This would go down, probably wouldn't be that great of a box. So let's make this mimic real life. We're going to activate the bottom drawer again. Okay, we're going to go into bodies. Oh, yeah, this was the OG drawer bottom. Okay. We're going to get rid of that one because while that kind of works visually, it sucks in real life. So we're going to get rid of that one and we're going to draw another one. So we're going to turn our sketches back on, but let's turn off the original one. We should name this OG.
So we're deleting it or just
No, we're just hiding it real quick.
okay?
Because again, it looks pretty. Look, I made a 3D model. But if you were to try to make this in real life by measuring each one of these pieces, going to Home Depot and making a drawer, this drawer design blows. Because if you were to stick anything in that drawer, because you would have a little bit of glue on that edge, a little bit of glue there, a little bit of glue there. Like you can't really put a screw into this 1/4-inch bottom. It's really not a structural drawer. It looks like a 3-dimensional drawer. You get an A for effort, but we want to make this so that I can make a thing in real life. So to make this better in real life, we're going to take this a step further. We're going to make a better drawer bottom. So we have drawer bottom as our active component. I'm going to make a new sketch. Now we're going to do some cool variables. I'm going to create another sketch on the bottom plane. Everybody following me? I don't want to go too fast. Okay. I'm going to project those walls again. Because again, I want this thing to update as the walls update. But now, I'm going to do a center rectangle. And we're going to use some variables. So now we're going to do dados in all 4 walls. I'm going to show you how to do this here. So I'm going to do the length. So it says drawer, whatever, depth, not length, drawer depth. Like, well, that is a really crappy dado. It goes all the way to the edge. Minus dado.
I'm sorry. Can you go back? I got stuck making the projections. It wasn't selecting it properly.
Okay. So when we go away, to make a dado, we can do a couple different things. We can offset this box outward into these walls, or we can make a rectangle on the outside, which we have variables for, and then make that minus some dado widths inward.
Okay.
Does everybody understand?
Yeah.
So there's really 2 different ways to make this drawer bottom. Let's do Shift R, which I assigned as my center point rectangle. Okay. I'm going to do a function. So that function, I'm going to do the drawer depth minus dado, which we assigned earlier. But that's only one dado. So that's just like the dado for the back wall. Now we have to do another one. So plus another dado, or dado times 2. Oh, I'm sorry, it's minus, my bad. Minus another dado. Everybody understand why I did that? Somebody doesn't understand why.
I don't know why you subtracted 2 dados.
Okay.
Be brave.
For the
So
front and the back.
our dado variable is half the distance of the material. So if I only did one dado, I have a front and a back wall. So that's really half the distance of 2 plywoods. Does that understand? So I need a dado on the front wall and a dado on the back wall. That's why I added 2 dado.
Oh, okay. I see.
And now we're going to hit tab. And this is drawer width minus dado. Let's see if we can do it times 2. There you go. Same thing. Now we're going to hit enter. Bam. Okay. So let's try one more thing. Let's hide that. Never mind. No, I don't want to confuse you. You can also do what's called offset. Does everybody have offset in their modify menu up here, right next to these scissors?
Yep.
So you can, if you were to highlight the walls on the inside and create an offset, you could offset outward the dado thickness as well, and that probably would have given you the same thing. An offset is a derivative, excuse me, measurement. So if you were to derive an offset off of this wall, which is updatable, then your offset will update as well. That makes sense?
Mm-hmm.
All right, so let's give this drawer bottom some thickness. We're going to hit E for extrude. So not only am I going to hit this center one, I'm also going to hit these little wings on the outside as well. Now, the only reason you have to do that is because there is a separate line. Then we're going to go up the bottom thickness.
I don't mean to be a butt, but mine
You're not
didn't
a
work.
Yours didn't work. Where did it
No.
not work?
So I did the drawer thickness or drawer depth minus dado, and it's still doing function, or it equals 18 inches. So
Okay. So you projected that,
yeah.
that and that. Okay. Actually, at that point, you didn't even need to project those.
No,
'cause
I
we're starting
didn't.
from the center. Okay. So Shift R to make a rectangle. So this is drawer depth. So that the drawer depth by itself matches the outside dimensions, correct?
Yeah.
Okay. Minus dado.
Oh.
It should shrink it a little bit.
Okay, I figured it out. It's just I didn't hit when I just typed in the word dado and I didn't select the thing at the
parameter from the
bottom.
little drop down.
Yeah.
There you go. And this one is drawer width minus dado. All right, you gotta spell it right. It's kind of crucial. Times 2, same thing. Enter. Now extrude that whole thing. Bottom thickness. Hit enter. So, what did this do for us? It created a little thing.
Yeah, it created a tool for us to cut out a dado from the walls of the drawer.
Thing pot. So I'll call that one dado bottom. So if we go back up here to our entire project, you can see it all. Looks almost identical to the last one, right? But you can see the walls are kind of feathered. It's because when those walls are feathered and not so defined like this one up here, it means that they are intersecting each other. So if we flip it over to the bottom, you can see that they are interfering with each other. So
What the heck?
What the heck? What?
Oh, sorry. For some reason, it doesn't want to like stick. So minus dado. Select minus dado. Select.
And hit enter. And hit enter again.
But then I didn't get the other shape done. I didn't get the other side. Yeah.
Oh, hit tab. Don't hit enter twice. So do the dado, minus dado, hit tab.
What the fuck?
So when you're
And I gotta go back and redo it. Is there a way to like go in and enter it if you mess it up?
Yeah.
Or is it
Whenever you hit enter, it'll give you like the little dimension bars where it says like FX that. You double click on that.
okay? So drawer depth minus dado tab drawer width minus.
I believe in you.
Oh, see, I hit minus dado and then it deletes the drawer width. So drawer width minus dado minus dado. Can I share my screen, Josh?
Yep.
Okay. So I'm gonna hit back real fast. Oh, hi, there's my face really big. Okay. So I'm just gonna start it again.
Okay. So you're on sketch number 2. Yep.
Sketch number 2. I'm gonna rename it drawer. Bottom. Or wait. What were we naming it? Oh, drawer dado bottom.
Sure.
Sure. Whatever. Okay. So I'm in the sketch. So
you don't right now. You don't need to project.
Okay.
Because you're using the parameters to help you. You shouldn't need to project at all.
Okay, so then I can just kind of hit
cancel
on
that
this.
project.
Okay. Yep. So when I go to do the create rectangle,
Mm-hmm.
I bring this out. I don't really need to move. I don't need to touch anything. I just need to do drawer depth minus dado.
Yep.
Minus dado.
Yep. Tab.
Drawer width minus, and see, it just disappeared. But I didn't touch my mouse.
I don't actually click on the thing. So just type in drawer again and then arrow down. See it, and then hit enter. And now keep typing. Enter. As soon as you start typing, and then the dado, enter. Now hit enter again.
Okay. Cool. I can stop sharing now.
Okay, so hold on.
Oh,
so right now you've got a lot of sketch elements going on there. That's not a bad thing, but to confuse yourself or to declutter your area, you still have your drawer component sketches on. So you can go up one more to the orange drawer and then go to its sketches and turn that one off. Yeah, there you go.
Okay.
And then put your drawer back on. There you go. Okay. Everybody good?
Yes. Thank you. I apologize.
No, you shouldn't have to apologize. This is why we're doing this. All right. So extrude that up the bottom thickness. And let me know when you're ready.
Okay, let's go back to the top-ish. Extrude. Why is this one not why can't I see it? It doesn't let me see the bottom thing.
Hold on, share your screen again.
I feel like an idiot right now.
Nope.
I went to go extrude.
Oh, because you turned off the sketch.
I hate myself.
There you go. But make sure you get not only the center, you get those little rectangles on the outside too. But if you go to the bottom, right now you're trying to select through some stuff.
Yeah.
You can either completely turn off that drawer to get rid of those walls.
Mm-hmm.
If it does get in the way, that's up to you.
Okay.
But just make sure you select the outer perimeter to the dado bit.
Okay. So.
Nope, drawer. Bottom thickness, I think it was called.
Oh, yeah.
But right now you don't have those outer walls. Yeah, so hit cancel. So hit E for extrude. Actually, you got to turn on your sketch.
Oh my gosh.
Turn on sketch. There you go.
Okay.
Now select. And this is where yeah, there you go. Make sure you get that bit too. And then there's one down there at the bottom. Hold on. Hold on. You're missing a chunk. Wait a second. Get rid of the drawer. Hit the little eyeball next to the drawer.
This one?
No, the actual drawer, the orange one. Okay, so something went awry here. Yeah, one of your dimensions is missed. Hit cancel. Okay, go to the bottom of this thing. And then just click on the button. There you go. Now zoom out. Let's make sure that this is center that thing. Okay. Now hit your drawer dado bottom sketch. Yep. Now hit E for extrude. So you want that and that little bit at the top. That guy. Yep. And the big part. There you go. Now extrude that upward, which should be a positive. the bottom thickness. Enter again.
So
Okay.
if you're like extruding or pulling a dimension or whatever, and you start with a minus symbol, will it go the opposite direction?
Yeah, depending on how you have your sketch oriented.
Mm-hmm.
Sometimes to make positive headway, you'll need to use a negative dimension.
Sure.
I mean,
okay.
This is where like the visual element of Fusion really works, because if you want to eat into something, it's not always a negative. Like it's interfering. So depending on how you have it oriented, it may be a positive, it may be a negative.
I got you.
Okay, so does everybody have what I have? You have the bottom is interfering with the walls now, correct?
Yes.
Okay. So in woodworking terms, if we were to remove this from these walls, which how did we do that earlier?
The combine tool.
Fantabulous. We're going to only do one wall because I want to show you something real quick. So we're going to combine tool. We're going to have this wall be the target because I want to take material away from it using the bottom. We're going to cut. We're going to keep those tools. Hit OK. Okay. Now go back to your drawer bottom and hide it. So if you spin it around, what did we make? Made a rabbit.
Where'd it go?
Yep.
So that's what that is called. We made a rabbit, but just on this one wall. We could have done it to all the walls.
Right.
So on these 4 boxes, let's say we use pocket joints or pocket hole screws or brad nails. You flip the box upside down. You take a rabbiting bit and a palm router and you zip, 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 zip all around there. That's what that means. So we're going to undo that, and then we're going to actually move the bottom up a little bit into the wood to make a dado. So there's a couple ways. You can hit the Command or Control Z to undo it, or you can go down here on the timeline and you can drag that arrow, that little cursor, backward. And then it's like we went back in time. Is everybody with me? So that's just an example. That's one example. If you wanted to do a rabbit on the bottom, that's how you can do that. But we want to make a dado drawer because we're fancy and we want it to be strong and we want to prove to everybody we know what we're doing. Let's turn our drawer bottom back on. And now we're going to move it. We're going to move it up a little bit. So to move something, you can hit this arrow up here, the move copy, or you can hit M. There's a couple different ways to move stuff. You have a free move, which gives you full rotation, full free movement. You can do a translate, which just does X, Y, and Z. You can rotate it, which you can set a pivot point. You can go snap point to point, or you can do the point to position, which I've never actually used. So right now we're going to use the free move. And as you see, you can snap it to a certain element, which just allows it to rotate easier. So we're going to snap it to the bottom right there. You can rotate it freely. You can type in an angle if you want, but we're not going to type in an angle. We're going to grab this and we're going to move it up vertically. So now we did not set this variable, but let's just move it up, whatever. It went up ½ inch. This is just a visual, ½ inch, enter. Everybody get that thing moved?
Yep.
Okay. Now we can do our combine tool. This wall is the target. That thing is the tool. Hit OK. I really wish you could select more than one target, but you can't. We're going to do all 4 walls here. This wall with that thing. Combine tool, back wall with the bottom. Okie dokie. Where's the front of my box? There's the front of my box. So now you can see on the inside, there is not a feathered edge, but like a very clear delineation. So now if you hide your drawer bottom, wait a minute, something messed up here. Maybe. Nope, it didn't. Now we have a nice clean dado in the bottom of our box. So if you go to cut this,
Didn't do any of that.
you know where to set your table saw fence, you know where to put your blade. But now we're going to show you the coolest part about Fusion 360. Who is not with me right here, either on screen or in their understanding? Everybody's tracking?
I understand, but I missed something, and just Turi's showing me how to do it really fast because he figured it out.
Okay. Let me turn the bottom back on. Let me know when you're finished.
Half an inch.
Okay, hold on 1 second. So do it, Tur?
Pull up about do half an inch or wherever.
0.5.
There you go. Very good.
Okay, so then what am I doing?
So now,
Once you have the bottom moved,
now
Yeah.
use the combine tool,
Okay.
and you're going to remove the bottom from the wall. So the wall is
Make
your
sure-
target. The
Okay,
bottom is your
so
tool.
wall is target, bottom is the
Yeah.
tool, and
Tool.
then we're gonna do the
tools,
cut.
You're going to cut and keep
and then if
the
you,
bodies, or keep the
basically
tools.
hide
I
the
want to
bottom, just hit cut.
Yeah. Okay. Cool.
Cool.
Yeah. Sorry, I was in the middle doing something else,
No.
and then we got really far ahead.
Sorry, is everybody with me right here?
I'm with you, bud.
Okay, this, we're about to separate SketchUp from Fusion 360. You're about to see all of your labor come to fruition right here in the dumbest, geekiest, nerdiest way. Okay?
Okay.
We're going to go back up here to change parameters. I'm going to minimize this thing, make it a little smaller so that you can actually see what you're doing here. Because you want to see this because it's cool. There we go. So this is the drawer front. Right, this wall. Let's change the width of the drawer. We want to change it to an 18-inch drawer because we measured wrong. Bam. Now you see that it expanded from both sides, right? Both sides went out equally.
Yeah.
That's because we created a center point rectangle. And now the drawer height, let's say this isn't a drawer on the side, it's the one right underneath your desktop that holds like your pens and crap, so it only needs to be like 3 inches high. Bang. And we don't have any 1/2 inch plywood. All we have is 3/4 inch plywood, so we're going to change that too. Bam. Everything updated. Even your dado updated. Hide the bottom. Even your dado is still half of the thickness of that piece of, stop it. Even your dado is still half the distance of that 3/4 inch plywood, which would then let you know where to set your table saw height, where to set your fence. If you're visualizing this thing, you can create a copy of this whole thing with the move copy and create multiple drawers. I just hit Command Z to undo. All of the things will update together. Where in SketchUp, I would have had to fix this one. I'd have to go back and fix that one. And if I did that, I'd have to move this one and then go move that one. That thing wouldn't update. All this stuff is parametrically joined together because of the way that we created our relationships. We started with parameters, which are super important. Every time we drew a shape, we used the parameters as its length and width, even diameter for circles. When we drew another component, we still used the same center origin. That's a preference that I have. We went back to the variables. If you can't use the variables, then use a projection of a thing that does have variables and then build off of that. Mirroring also works really well. We could have mirrored these rectangles in our original sketch. I could have drawn one with variables, drawn a line off of the center point, and then mirrored it against that line. Those also update. So again, this is a super simple, I know this took a while, but I hope you have a little bit of confidence in Fusion that you made a thing. And not only did you made a thing, you made a thing correctly. So this is episode 1. We can We can eventually do what Nicole wants to do by adding a canvas and working off of a picture of a shape. We can do that too. Maybe another day. It's getting kind of late. But I hope this gave you a little bit of confidence in Fusion so it's not so crazy. It's not so cluttered. You made a thing. And you made it well. Does anybody have any questions off this thing that we just did?
I muted everybody because there was some feedback we were getting at the end. So you had to unmute yourself if you want to talk.
Yes, please.
I want to say thank you because now I have successfully made a box and I
You sure
know
did.
what I'm doing ish. I know what I'm doing enough to
I want
be
to show you one
dangerous.
thing that you also made. So right now, you're looking at your box. You can take that cube up in, instead of, let me see. I can just do it instead of talking about it. Dingleberry. Okay, not only did you make a box, not the top. We're going to rotate it. Okay, you made a cabinet. And let's say you want to put some shelves in that cabinet. Let's take, what is this? The back wall. Let's hit move copy. I want to check this create a copy. And then move it down. Or, even better, you can create a pattern, a rectangular pattern of not a face, but a body. This body. I want the direction to go that way. I want them to be spaced, say minus 12 inches apart. Forgot how big we made our box to make this video make any kind of sense.
If you use your parameters, Josh.
4 inches, whatever, and I want that many of them. Well, that looks stupid. So we're going to use this and we're going to combine. So now you made a bookshelf.
You could do height divided by 4, so it's like even and all that stuff. Yep.
Yep. So not only did you make a drawer, you make a bookshelf, you can make a divider for your forks and your stuff. You can flip this over and you can hollow this thing out and you made a desk. Like this same basic principle, if you think about it in woodworking terms, most things are derivative of a box of some type. And so this is just to scale now. In 3D printing, if you were to make a 3D printed box, you would, rather than like purposely doing, I want to extrude this side and this side, and then be done, and then extrude this side and this side so that they don't touch. If you want to make a 3D printed little cup or whatever, just do all 4 walls at one time, bring the whole thing up. And now it's one unified piece. And if we wanted to 3D print this, we could right click right here. You could save it as an STL, or we could go to tools. We could click 3D print. And since we have the entire model selected, we can export that entire thing and it'll bring it into a slicer. Actually, I think this have it set to Cura, and this is an outdated version of Cura, so it might mess up. If you wanted to take an entire brick of wood and you wanted to CNC this entire brick of wood, you could totally do that too. It takes a little while. But the point of this, the whole point of this whole thing is to go back to those 2 main elements. Your design criteria, or your design intent, rather. Or you make it model real life if it needs to model real life. If you're going to make just something conceptually, you might not have to do that much work. And then designing for change, because you're probably going to get it wrong on the first go around. Or if you take this model, you can send it to somebody. This is how we work at I like to make stuff. I make a model of whatever it is that we're doing. I send it to Forby, and he turns that model into digital plans. And he goes, oh, this thing is a little bit messed up. I can go in and I can tap 2 numbers and everything is fixed, rather than having to spend an entire day going back and changing the entire, I got to start all over again. It's ridiculous. Fusion is dope. That is, we didn't even skim the surface. Like, you know what the surface looks like.
Yeah.
There's a lot to it, but those are the basic foundations. Does anybody have any questions? And if you want to plan the next one, we can plan the next one. We can do the modeling to a canvas with pictures if you want to.
I did figure out how to put pictures in earlier. I was messing around with it earlier, but I think this was good to start to understand how to properly layer stuff. Because like obviously we went to your class at Workbench Con, and that was super helpful to just kind of understand that layering is important. But this is actually seeing it and doing it, and this changes a lot. So I think now I'm going to try to play around with it, see how far I get, and then if I have questions, I'm going to bother you with them.
Well, with the pictures. So what she's talking about is you can take reference photos. You want to take a straight on all of the X, Y, and the Z so that you have an accurate kind of cross section, the flattest, most straight on image that you can. But
a projection, if you will.
Not necessarily. You would like to.
Sure.
A photo, you kind of do your best.
I'm with you.
In those pictures, make sure you have a ruler, or make sure you have a known image or a known kind of measurement tool of some kind in that picture, so that when you import the picture, it is not to scale. It'll show up in the tree on the left side. I think it's mesh or canvas or something. And then you keep like going down the list, and it'll have your image. Right click on it, and there's a little thing that says calibrate. Click calibrate, and then you can like click a point. You click a point, and then you can enter in a distance. So in that picture, if you have a ruler, you click in this to this is 1 inch, or this to this is 1 millimeter, and then your image will be to scale, so that if you were to make a 3D print from that thing, it is the actual size that you want.
Cool.
Exporting to a slicer. If you model in inches and you export to a slicer, it will be super duper tiny. If you are going to send something to a 3D printer, model in millimeters, so that when you bring it into your slicer, it will be to scale also.
Can it just not read inches?
Fusion's default unit of measurement is the decimeter.
Excuse me?
Super stupid. Yeah. So when you do in inches, it gets a little confused. And when you export that out, the receiving software just sees a value. It doesn't necessarily see that it is an imperial or metric value.
Okay.
Yeah.
Cool. I feel more confident than I did an hour and a half ago.
Huzzah.
Huzzah.
Does anybody else have any questions? I'm here to help.
I think Fusion has a built-in slicer now too. I heard.
Yeah.
I mean, it probably counts still, but
I tried to dive into that one day and went, I could have been done by now.
yeah.
So I'm just going to use Prusa Slicer because it's super easy, or Cura if that floats your boat. But like, I tried to go through and use it, and it has presets for different printers in it. Still wasn't as easy as saving STL, opening it, clicking slicing, printing.
Is this something that you could bring an STL in that you find in like Thingiverse and mess with?
Yeah. But
that's a big but.
Big cap.
I'll bring this up. I'll show you this one real quick. So I, like all cool kids, have a 3D model of my head.
So weird, Josh. Why?
I mean, why not?
You're right.
I have a 3D scanner. I have a head. Bing, bang, boom.
Because the internet.
Where is that thing?
How could you lose your head, Josh? That's
a
shame.
Okay. So, let's do this. So this STL was made by somebody else. Now you see it's broken up into a whole bunch of little triangles.
Yeah.
Different 3D software types use different three-dimensional geometry. This uses a bit rep, and a bit rep is a triangle, and there's other types, but Fusion uses bit reps. Fusion, because of some of the limitations in Fusion, it has a facet count that it cannot go over.
Okay.
I think if you were to try to input a model and try to use it, it'll tell you, I think it's like 10,000, but I think the real number is 20,000 facets. So you kind of have to like low poly it and dumb down an external STL so that Fusion doesn't freak out and crash. And if you want to alter it in any way, how do we do this? You right click on the project.
Yeah, you gotta turn off design capture history.
Turn off the timeline. Do not capture design history. Because the design history down at the bottom that we've been doing will update every single thing in the model. And it updates 20,000 facets every time you do something. It will overload it. It will freak out. So you have to turn off the timeline, and then you can start to mess with it.
Okay.
So you can input everybody else's STL. The faces, if it's a flat face, it'll get broken up into really weird triangles. So it's not the best at doing it. I usually use Mesh Mixer to alter an existing STL. But Fusion can. It's just kind of, it gets fickle. And it's like,
So
I don't want to
then,
do
kind
it.
of a backwards question then. If I were to make an STL from Fusion, share it on oh, that's hilarious. Share it on Thingiverse. And if someone were to download that and try to mess with it in Fusion, would it then have a million triangles in it?
Yes.
Yes, because it's an external STL.
Okay, cool. Just wanted to try to understand.
Yep. But that's if
What
it's
came
really
first, chicken or the
organic
egg?
and flowy. If it's a block shape shouldn't really be that difficult. It'll
Okay.
input it into this pink color. Let's actually try it. Don't do that. And it goes, hey man, if you mess up, there's no design history. It's on you. I'm like, yeah, I know. That's fine. And now, let me see. I want to modify.
Does that mean you can never like undo?
You can still Control Z, but you can't roll back in the timeline.
Okay.
Yes. And then you convert a mesh to a B-rep. Want that one? Okie dokie. Yeah. No.
Jesus.
Yeah. It just said no, thank you. So
Okay.
and I'll do that in double save. So for the head that I made of Bob, this is exactly what I did. I took his 3D scan from that same day, and I imported it. Where's that crap? 3D bits. And then I made him. I split it in half because I was going to put stuff on the inside of his head, which you can do by just splitting a model with a construction plane. So he has right side of his head and he has left side of his head. So I did that whole thing. Notice there's no timeline down here. I took it into Mesh Mixer and I reduced the facet count.
You
That's
can
what I
do
did.
that in Fusion too.
Okay. So I brought it into Mesh Mixer because it had his shoulders and everything too. I did a plane cut and I cut his head off. Then I cut his head in half. So that I worked on each half. So each, like, instead of my entire head having 20,000, each half was allowed to have 20,000. That makes sense.
Okay. Yeah.
So then I could go in here and I could hollow out spots. Like, see these crazy triangle things? Like, this is all like flat face. But
Yeah.
when it comes into Fusion, you can select a whole bunch of these and then like extrude them together and it'll make it a flat panel and then like push the panel back in and do that a bunch of times. It's kind of crazy. But you can. Fusion just doesn't really like it.
Cool. Well, that's good to know.
So I made him a hair plug. Yeah, and that's why I added hangers to the back. And this was just, I drew a triangle, I pushed it in, and then I gave it a chamfer on the inside so that like a screw could sit up inside it.
Yeah.
Oh, that's a good idea.
Yeah. So yeah, there's silly ways to do a lot of things, but
Is that to make soap come out of his nose?
Yeah.
That's amazing.
yeah. SVGs is another thing. You can import an SVG, but Fusion doesn't like vector graphics because every time you update something, it gets kind of overloaded. So adding text to something in Fusion, the text element sucks, and they know it.
One thing I've done that has been useful is I've gone You can actually import some parts straight from a master car.
Yes, that was one thing I didn't get to. That was going to be
Next
kind of in
time.
the next lesson. You can import them, and then you can add joints to them.
Yeah.
Which is crazy. What are we doing here? So in the insert, you can insert the canvas, which is what Nicole was doing. You can insert an SVG. So if you wanted to add a very specific type of text, fill it out in Illustrator, save it as an SVG, bring it into Fusion, then extrude it up. You can import a DXF, which you can actually export a DXF for a laser cutter or for a plasma cutter. You just export the sketch instead of the model. And like you're saying, in the McMaster car, you can search for. Actually, that's funny. I needed one of those. I need one for a motorcycle.
If you guys need isopropyl alcohol, McMaster Car is the only place that still has any.
That's dope. So you find the one you need. You click on that particular part number. Go to product details. Scroll down. And instead of SolidWorks, you click step file and hit save.
Also, if I want to like 3D print these, I can even just take their parts and 3D print them.
Yep.
Cool, cool, cool.
Yeah.
And you can also make a hole. There's a hole tool and a thread tool that will match real life threads, real life screws. So you don't have to like manually try to add a like countersunk screw hole. There's a function that will just allow you to do that.
Okay.
So anytime you import something into a model, you get one free move. Because right now this has no origin. So you can move it wherever you want to. You get one free move, and as soon as you hit enter, now it's locked to that position, and now you move it with the move command. But because this is round, it wants to snap to the roundness. But you can, there's a better way to do it. You can import models from things you've done elsewhere into it. I want to insert this one, say, drawer cabinet. If you're going to do an entire kitchen remodel, you can make one drawer cabinet, make it variable, like we have. And I want to insert it into this thing. You get one free move. So if you're doing like a collaborative project in like a group environment, say somebody's going to work on the modeling the cabinet for the refrigerator, someone's going to be working on an island. You measure your kitchen space, you send that out to everybody. They can all work on their individual pieces. Then you can import them into this place. You get your one free move, and as soon as you hit OK, because it has that little link right there, if, say, a person who's working on the kitchen island updates something, it will update into your current entire kitchen model, which also means that if you try to move this little guy in your kitchen model, it will move over here too. If you don't want that, if you just want to like use your project library as like a, I don't know, a repository for models, you can go in here, you can import it, and then you can just break the link. Yeah, I know. And then you can move it all day.
Okay.
So very good for collaboration. But if you move it into the thing you dropped it into, it's also going to move it over here and vice versa. Fusion's dope. And if you want to send this model to somebody, say you made a render saves it as like a JPEG or a PNG actually to your desktop. But if you wanted me to update yours, you want somebody else in your working group to update a thing, what did we call this? Fusion test. Where's Fusion test? Oh crap, where's Fusion test?
Can you just search?
Maybe. I think I put it somewhere. I put in house projects by accident. Whatever. You can right click and you get share public link. So you want to share that, and then you can allow it to be downloaded. This link, you send this to people and it will populate a pretty decent render in a browser window. So if you want to send something for approval or just to get a concept to somebody else, you can send this to them, and it will not open in the Fusion 360 application in which we've been working. It will open in an online portal where someone can spin it around. They can like hide different components, but they can't alter it at all. If you allow the item to be downloaded, they can download it and then open it in the app, and they can work on it at their leisure. It will not update your existing model. It will just give them like a brand new one.
Cool.
Cool.
Cool, cool, cool.
All right. Who's got next class? Who's teaching what?
I don't know. Wes is just starting a curriculum for everybody.
Well, I was planning on doing a soldering one if anybody was interested in that.
That's a good one.
I'm looking to learn.
I have some little kits that I ordered for my local maker group that I'm willing to send out. They're like it's like a little PCB board. It has like a little LED light and a battery holder. I think it has a battery with it. Depending upon which one I send, it might also have a little button. And it's just like simple little things to solder just to have the same thing to look at as my example. So as long as you have an iron, some solder, and well, that's it really. And just the piece, I'll send it out to you if anybody's interested in attending that. If I don't have your address, I'll get it from you. But
I'm raising my hand if you can't see my hand.
Got it. So I got Nicole. I don't know who else is interested, but I'll just post it up and you can let me know later on or whatever. I was thinking maybe, I don't know, once a week or something.
I'm down for things.
Cool.
This is crazy, you guys. But this is fun.
I mean, might as well do it, right?
Yeah. So we got D&D class possibly beginning of the week. I'm going to see those jokers and we're going to talk about it and pick a day.
I would like to get in on the D&D side.
I can't have too many people in it. That's the only problem. So the game itself is set for max of 6 people, because D&D is kind of crazy. So I have 5 right now, and I wanted to leave it up to Josh and his team to decide if you guys really want other people in it, since it's mainly meant for you guys to learn how to play D&D as a group. So,
I mean, if you have space, Clint can come hang out.
Yeah.
I don't know how many of the 4 of us. I know at least me and Bob and Anthony. I don't know if Forby wants to play. I don't know. Did he go into the? Mm-hmm. Okay. Well then, yeah. There's at least 4 of us.
And Terry's gonna play, so so you guys know what to do.
Okay.
It really depends on what time it is as to whether I'll be available.
Well, yeah, it's a 3-hour commitment and it's on their schedule.
Okay. I will get you that answer at least by Monday.
Whatever. I mean, just throw it in the chat. So.
Okay.
Cool.
All right. Well, this has been fun.
Sweet.
I hope this has been helpful. The best advice somebody gave me, now that you are armed with a little bit of knowledge, is take a thing that you already have, right? Get some calipers. Calipers are your best friend when working in Fusion. And
good one.
Recreate that thing in Fusion 360.
Can do.
One thing we didn't go over is appearances. You hit A, and an appearance menu will pop up. And it has wood, plastic, water, metals. You grab it and you drag it onto that body, and it'll turn it into a piece of walnut or a piece of cherry or a piece of whatever. So you make it look like a thing, not just a big gray amorphous blob.
Mm-hmm.
So
cool. Well, Josh, thank you so much for your time today.
Absolutely.
Yeah. This is super helpful. I appreciate it.
If you have any questions, let me know.
I will. I know how to get in touch with you.
Yeah. I'll be here in this office more all day. Every day.
By yourself.
A few more months.
I'm going to bed. So
Okay.
you guys have a fantastic evening.
You too. Bye.
See you, buddy.
Bye now.
How do I go?
Guys.
Just
Like,
See ya. And we're done.